afternoon, and good evening to everyone. I'm Dr. Shipra Kumari, and I am an assistant professor in Department of Mathematics, VJTI, Mumbai, India. I'm come from a mathematics background with my research focused on Hadamard matrices and their application in cryptography. It is a truly an honor to be a keynote speaker in this wonderful conference Horizon 2025. So, when we think of progressive research in humanities or societal development, mathematics might not be the first thing that comes to mind. But in today's technology driven world, mathematics quietly powers nearly every aspect of our lives, from engineering and computer science to economics, linguistic, and social sciences. The language of mathematics transcends disciplinary boundaries, creating connections and solving real world problems through elegant mathematical framework that drive innovation across multiple fields of study. So, the three major innovation reshaping our collective future are AI and machine learning, network science, and social graphs, and the third one is quantum computing and cryptography. So AI and machine learning, these systems are powered by linear algebra, probability, statistics, optimization, and graph theory. These are the basic core tools of the mathematics which has been used in AI and machine learning. So basically in the linear algebra, the basic concept of linear algebras are vectors and matrices, which has been used to represent the data. So if we have a photographs, then we store the photographs in matrix form using pixels, right? And the second basic concept is linear transformation, which is the rotation, scaling, and projection, which used to manipulate the data. Like, it is also used in pattern recognition. And in AI and ML, we have suppose we have a data set, and there are some missing values, or there are many features, and we need to trim, or we need to clean the data. In that, we use eigenvalues and eigenvectors to reduce the number of dimension by keeping the most important information. Solving system of linear equations, matrix multiplication, transposition, convolution, and many other linear algebra operations form the foundation of artificial intelligence and machine learning. So we basically know that in AI and machine learning, we use linear algebra, statistics, and probability, right? So the second most important tool in AI and machine learning is statistics and probability. In real world scenario, data is noisy, incomplete, or unpredictable. So probability helps us to quantify uncertainty and make decisions even when we are not 100% sure. Whereas statistics is the backbone of machine learning. It helps us to extract meaningful insights, build models, and evaluate performance. It enables machines to learn from limited data and generalize to new situations. And the second major innovation is network science and social graphs. So, mathematics, especially graph theory, linear algebra, so basically, graph theory is used to model relationship, analyze structure, who is central, who is isolated, who has more friends, detect communities or influence, simulate information spread or epidemics. So, social scientists use network theory to study power dynamics, trust, and community structure. And strategists use social graphs to find influential voters and simulate massive spread in population. So, we can say that mathematics is used in in society also. In opinion poll, when voting happens in opinion poll, we use a graph theory to predict the result. The third one is quantum computing and cryptography. So when we send a message on WhatsApp or whatever, if we share any information, secret information, we expect privacy. What ensures that? That is cryptography, right? And cryptography is a field that relies on algebra, number theory, and matrix structures like orthogonal, Hadamard, and conference matrices. I work on orthogonal matrices, Hadamard matrices, and conference matrices too. So linear algebra, probability, statistics, these are the basic core mathematical tool which has been used. And mathematics also helps to analyze pattern in philosophy, history, literature, and arts, bridging with the humanities and society. The most exciting frontier lies in the intersection of mathematics and human understanding. The digital humanities historical tests are analyzed using NLP, natural language processing, ethics in AI. The mathematical fairness matrices meet moral philosophy, and behavioral economics, game theory, and psychology converge to influence policies. The fusion of logical rigor and human insights will be what defines the next era of research. So, thank you.
Thank you so much, ma'am,